In this video, we are going to make a small web interface for an Arduino device. So we want to create a button in a web page that when clicked will make a change on an Arduino device. Now, as far as I know, you cannot talk directly from a client, a web page using JavaScript, to the Arduino. So we're going to create a Node.js server that sits in the middle and passes messages back and forth. So the full process will be a web page. You will click a button on a web page. Using socket, it will send a message from the web page to a Node.js server. The Node.js server will use the serialport node package to then send a message to our Arduino device. And in our example, we're just going to turn a light on or off. So to start, let's create the Arduino circuit. Okay, so let's start by creating a really basic circuit for an LED. So I'm just going to go from our ground to our breadboard. Then through a 220 resistor. Then an LED. Remember, keep the short side towards our ground signal. And finally, close our circuit with our 5 volts. Now, if I plug this in just as is, okay, so our LED tells us that the circuit is working. Now, what we're going to do is we're going to disconnect our 5 volts, and I'm going to connect this to our digital signal port 2. Okay, I'm going to use the online Arduino editor to write my code. And I have a sketch here called Node.js to Arduino. So to start, I'm just going to define a variable called light pin. This is just going to store which pin the light is in, and mine is in number 2. I am then going to initialize that pin and let my Arduino know that this is for output. Next, we just want to get our serial up and running, our serial port. And that is everything we need to do for setup. In our loop, we are going to check our serial and see if there's any data coming across. So we're going to see if anything is available. If something is available, we're going to create a variable called received string. Then we're going to create a loop that is going to run as long as there is more data available. And if there is more data available, we're going to take our receive string variable and add to it the next piece of data that we received. Once that's done, we're going to check it. If the received string equals 1, then we are going to turn our light on. Otherwise, we can assume it's a 0. Okay, so I'm going to save that, and we won't see any result at this point, but if I upload it, oh, we have an error, so I just have a typo here in begin, so I'm going to fix that and retry. And I have another error, and here I just forgot the brackets, and try that again. Okay, and that's uploaded. We won't know if it's working until we get to our Node.js, but at least there's no syntax errors. Our next step is to get our Node.js server communicating with our Arduino. So to do that, I need to install the Node package serialport, and I want version 9.0.1. Then I can just do an npm install and download our serial package. Next, create a file called app.js, and in here, let's just get a message going from our Node.js file to the Arduino. So we won't worry about the web page at this point. All right, so first we need to import our serialport package. And then to use our serialport, we need to set up a parser. We are going to tell Node.js that our data is going to be parsed by new lines. And the character for a new line is /r/n. Then we want to set up our port settings. Now in here, we need to specify the location of our USB port that the Arduino is attached to. Now in the documentation in the GitHub repository, there's instructions on how to do that using the command line or terminal. However, you can also do it by going back to your Arduino code editor, and in the dropdown where you choose your Arduino board, this is the text, the string we're looking for. On a Mac, it typically starts with dev. On a PC, it's got the word com somewhere in there. So I'm going to go back to my Node.js and just place that in here. Now I need to take my port and attach it to my parser. Now I want to make sure this works. So I'm going to take my port and just write a message of 1. Okay? The Arduino is set up so that if it receives a 1, the light will go on. If it receives a 0, the light will go off. However, if I run this line right away, the port won't be ready to go. So I'm just going to add a set timeout. I'm going to wait 3 seconds. And then send my port.write. So now if I go node app.js, notice the Arduino, in about 3 seconds, our light turns on. So that tells us that our communication is properly getting from our Node.js server to the Arduino. The Arduino is receiving the message, and the 1 is turning on our LED. All right, now let's make our web page. So open up a new file called index.html. And in here, just put the basic HTML tags. And in our head section, I have this copied, but this is the location of the socket.js library. Okay, in our body, we're just going to have a title. And 2 buttons. Call one light on. And one light off. Okay, in our script, we're just going to create a variable called IO or socket and initialize socket. Then we just want to add an event listener to the click for our 2 buttons. And for each click, we're just going to emit a message to our Node.js server. So we're going to take our light on element, and when our light on is clicked, we are going to take our socket variable and just emit a message. When we emit a message, we specify the name of the message, so I'm just going to call it lights. And using object notation, I'm just going to pass along a property called status and set it to 1. I'm going to take our light off button, add an on click, and this time we will take our socket variable emit a message called lights, and this time send a message of status is 0. Okay, I'm going to save that. That's all we need on our web page. Next, we can go back to our Node.js code. All right, in our Node.js, we just want to create a basic web server. So let's just use built-in Node.js libraries. We'll use the HTTP for our server and the file system just to grab the contents of our index. And let's just grab the contents of our index file right here. Right, and then after we set up all of our serialport stuff, we can comment this out. We'll leave it in for testing in case we come into a problem. I'm going to create an app. And when a request comes in, we're just going to take our response, pass along a 200 response code. And then pass along our index page. Finally, we want to take that app and just tell it to listen on port 3000. So let's test this here. And now let's switch to a browser. And if I load localhost 3000, we get our page. Now at this point, our Node.js server is not listening for our socket communication. So that's our last piece. So go back to our Node.js. After we set up our app, we want to set up our socket. So first, let's create a variable called IO. And require socket. Take our I variable, and when a connection is established, we're going to run this function. We're going to take our socket connection, and we're going to listen for an event called lights. You'll notice that that is the name of the emit that we used in our web page. When that is received, we're going to run this function. And we're just going to take our port and write to it from the data we received the status. And then just for testing, let's just do a console.log data to make sure we're actually getting a message from our web page to our Node.js server. And I can save that and rerun our app. Okay, and we just have an error. One thing I forgot is when we include our socket.io, we need to specify that we want it to listen to our app. Okay, so we'll try that again. Okay, no errors, so I'm going to switch over to my web page. Refresh, and let's open up our console to see if we got any errors on our front end. And I'm going to click turn light on. Okay, no errors. If I go back to my Node.js code, okay, we can see that we have received a status of 1 and no errors. And if you noticed on the Arduino, the light is now on. And let's go back to our browser. Click light off. And if you watch the Arduino, now both buttons are working without any problems.